The earth is flat.
Okay, you guys. So pretty much, many of you guys were not here when we went over this topic on stoichiometry because of testing. So what we're going to do today is, for those of you that were here, good. It's going to be an additional review. But for those of you who were not here, you're going to learn stoichiometry. So pretty much, this is nothing but math. Looking at this chart right here, this chart pretty much tells you everything you need to know in terms of the calculations, okay? So I kind of pretty much just took everything and just put it into one chart. You guys can go on and write this down. Also, for your quiz, I will always include this chart for you guys as well, so you guys will have this present. For you guys, because of testing, it looks like you guys are going to be, you guys are going to be testing on the 8th, you're testing on the 9th, 10th. You guys are testing all of next week.
Jeez.
Yeah.
Okay, only this class. And then, so what we would end up doing is, your quiz is going to likely be on like the 18th or the 19th. Uh-huh. Yep, actually I have you guys testing on the,
19.
so yeah, so we gotta figure it out because you guys' schedule, because of this class, it's gonna be slightly different from all the other classes. Okay? But you guys will know well in advance, and then before class ends, I'll end up grabbing a packet for you guys. So you guys will have that, and it's pretty much just going over the exact same thing. All right? So right here, like as I was saying, like this formula right here, or this illustration pretty much tells you everything that you need to know in terms of stoichiometry. Now the way that you would read this is relatively simple. All you have to do is follow the arrows, okay? So in other words, when you're looking right here, first off, we're focusing on our grams, our moles, and our atoms. I've also included atoms, particles, and molecules, okay? So if at any time you have a question where I'm asking you to calculate or convert from moles to molecules, just know that we're using this here. All right? And so the way that this reads is, if we are trying to go from grams to moles, we're going to use this formula right here. If you notice, we have 1 mole over the molar mass. All right? So what this tells us is this 1 mole is constant. It will never, ever, ever change. Okay? So going from grams to moles, all we have to do is calculate the molar mass. Okay? How many of you guys remember how to calculate the molar mass?
Yes.
Uh-oh. Okay, just going back through the molar mass. Right here, let's say, for example, we had sodium and chlorine, okay? What's the name of this compound?
Sodium chloride.
Sodium chloride, right? So now the way that we would calculate the molar mass is by identifying the number of atoms present and multiplying that by its mass number, okay? So in this case, we're looking at sodium.
Is 1.
We have 1 sodium, right? The molar mass, you guys, what's the molar mass of sodium?
23.
Okay? If you look at sodium, you will notice that sodium's mass is 22.99, okay? But then when we go through and we look at the mass number is going to be the rounded version of that. So we're rounding to the nearest whole number. Just remember, if after the decimal it's 4 and under, the number would stay the same. And if it's 5 and above, we would just move up, round up to the next number. So in this case, we have sodium. We have one sodium atom.
And
So
it's
we would do 1 times 23
35
gives us 23, right? And then we look at chlorine. How many do we have?
is 1 times 35.
We have 1, right? And then chlorine,
Times 35.
okay? And we said 35 as opposed to 36 because chlorine's mass is what, 35.45. And therefore, because the 4 comes after the decimal, it's going to remain the same. So we keep it at 35.
So added in is 58.
Yep. So then if you remember here, all we're going to do is take these numbers and we're going to add them together. So right here we have 58 grams per mole. All right, so if you notice, a bulk of this already is going to deal with math, okay? But pretty much what we're doing, the purpose of learning to do stoichiometry, I always like to go back to medicine, okay? Let's say, for example, there was a natural disaster, and I shared with the class, the last class, that in the event that there was a natural disaster that occurred, and let's just say, for example, you guys needed to create like a saline solution, okay? With the basic knowledge of information that you guys have, with knowing how to balance equations, knowing how to calculate the mass, okay, of these atoms, you pretty much can create your own batch of saline solution. Of course, there's a few other things you would have to do. I had one student even ask me, what about the water? What if the water was contaminated? Okay, you can go through and use the distillation and filtration process as well, okay? So you're able to purify water with just taking something as simple as the coffee filters, okay? And so with the coffee filter, and you guys can try this at home actually, you can take like muddy water and then put it inside like the mud, the clay, the muddy soupy water, put it inside of a cup, okay? And then what you want to have happen is you want to poke a hole in the cup above, and then so you have a cup here. This cup has all the nasty stuff in it, like the dirt, the mud, okay? There's a hole right here. Next, you will have another cup. With this cup right here, this cup can have the filter paper. So I'm just gonna say FP for filter paper. But then this cup should also have a hole right there. Depending on how much you want to filter it, you can add another cup. And this cup will also have the filter paper. And there's a hole right there also on the side. And then this cup right here would be your purified water. Okay? And this, by the time you get to this point, this is drinkable water. Okay? Going back to the whole use of stoichiometry, just pretty much knowing how to do the calculations or the conversions is going to be big, because I said that you guys need to know how to balance equations, right? But remember, when we were balancing equations, for example, we had H2 plus O2 is going to yield H2O, all right? When we were going through and balancing the equations, these numbers that we had to fill in, for example, right here we have our 2 hydrogens, right? Here we have 2 hydrogens. Is that balanced?
The hydrogen.
The hydrogens are right. Our oxygens, we have how many?
2.
2. How many over here?
1.
What needs to go here then?
2.
What just changed?
The hydrogen.
The hydrogen.
Which is
What does this need to be?
2.
2, right? And now we're balanced. So what this number is really telling us is the number of moles of hydrogen that's needed, okay? So reading this now will tell us that we need 2 moles of our hydrogen gas to react with 1 mole of oxygen gas, and that's going to yield 2 moles of water. All right, but you guys, how big is a mole?
Oh, shoot. It's like a particle. Like I did so much.
Can we weigh a mole? No, right? A mole is unmeasurable through our ordinary laboratory processes, okay? So pretty much what we are trying to do is convert this to something that we actually understand, which brings us, hold on. Where is it? Now y'all know I'm not that well with this one. Is this one? No. No. This one? It's this one. Okay. So pretty much what we're going to do is just convert this to a measurable, something that we can actually measure in the lab. Okay. So in this case, we will be going from grams to moles, right? And then from moles to grams. So if at any point you're given, like going back to the whole balanced equation dealing with the water molecule, how we had the 2 moles of hydrogen gas, we're able to convert the 2 moles of hydrogen gas to grams. Okay? So now what we're going to do today is just focus on the first half. The first half is going to be on just pretty much going from grams to moles and then moles to grams. I like to say that this part is relatively easy. And then when you go towards this part, this is where we're going to need to go back to scientific notation in some cases. So what I'm gonna do is we'll do an example problem. I'm going to make this smaller, so I'm just gonna quickly redo this chart and then we'll do an example so you guys can kind of see what's really going on here. What color should I do it in?
Green.
Green?
Attention grabbing color.
So I'm just gonna put, oh, you know what? Let me make this smaller. I'm just gonna put MM to reflect the molar mass. Okay, so I'm just redoing this. So now, a sample problem or an example that I may use, we'll start off basic and then we'll kind of like do a little bit more, explore a little more. So one example might say convert seven grams of, we'll say, of sodium hydroxide Okay. Notice the abbreviation with the moles too. Okay. Moles, if you just add 2 more letters. Right here, we just have convert 7 grams of sodium hydroxide to moles. All right. So you guys, based off of this chart, where are we going? Where's our starting and where's our ending?
Grams to moles.
Moles.
Grams to moles, right? Now, the thing is, you guys, because sometimes it can get a bit confusing, always remember that wherever your number is, whatever unit is next to it, that's going to be your starting point. Okay? So, what I like to do is I always like to go back. I'm going to use another color. I like to identify exactly where I'm going so that I would not forget it as I navigate through the problem. So I'm going from grams to moles, right? So because I'm going from grams to moles, which equation am I going to use? Am I going to use the one down here, or am I going to use the one up here?
Down there.
The one at the bottom, right? So the one at the bottom tells us that we're going to have 1 mole over the molar mass. Also, another hint, you guys, as you guys kind of navigate through these problems, you'll eventually learn that when you're going from grams to moles, all you're going to do is divide. And then from moles to grams, you're going to multiply. But you'll see it here in the example. So right here, what we're going to do first is we're going to bring down our 7 grams. So we bring down the 7 grams, right? And then the equation that we use, the formula we're using, is a 1 mole over the molar mass. So I'm just going to rewrite this here. So 1 mole over the molar mass is what we're using. And so what is the molar mass that we need to find out? The molar mass of what? It would be the molar mass of the sodium hydroxide, right? And so now looking at sodium hydroxide, we have sodium. How many sodiums do we have?
1.
1. What's the mass of sodium? So times 23 gives us the 23. All right. And then what about oxygen? How many do we have?
1. It's times 16.
1 times 16 gives us the 16. All right. And then we have our hydrogen.
Isn't that 1 times 1?
So then you guys, let's go ahead and add these up. What do we get? We have
40.
23 plus 16 plus 1. Huh?
40.
So you see how we would normally write the molar mass as grams per mole? We no longer have to do that because in the equation we already have the per mole, right? This still says grams per mole because you have your mass per 1 mole. All right? So right here, we just go ahead and just take this formula and put it right here. So we have our 1 mole divided by our molar mass. 40 grams. Okay? And so then you guys right here, you will notice, like, just to kind of make sure that you're doing it right, what's up top should match what's in the bottom. So in other words, your numerator here on the side should match the denominator. All right, so that they can cancel out. Because although this says 7 grams, it's the same as saying 7 over 1. All right, so your grams cancel out. The unit that you should be left with is exactly what you're finding. So in this case, we're trying to convert to moles, so we should be left with moles. All right, so now that this cancels out, we just go ahead and multiply it across. So we have 7 times 1 gives us 7 moles, right? And then we have 40 by itself. So now what we will do is 7 divided by 40 gives us what?
Points. Points. Points.
Points.
Okay, it's point something.
It's point something. Leave me alone. 0.166666667.
Okay, so
Six,
we got
repeat it.
0.166, you know what?
Repeating.
It's repeated.
Just repeating.
No, I need to change the color for this answer.
How'd you get that?
It's 7 divided by 40.
Calculator's inaccurate.
I don't know. I didn't do a calculation. Do it again.
So what was the answer? 0.167?
Oh my god.
0.175.
Never mind.
175?
Guess what happened?
What
Guess what
happened to your calculator?
It added in a 0.
He put it in wrong.
Oh, human error?
Yeah, human error.
Okay, so right here, our
No,
answer
man.
is 0.175 moles. And it's 0.175 moles of sodium hydroxide. Okay, so all this is doing is giving us a direct conversion. All right?
Do they need to use this in hospitals and stuff?
Do they use it in hospitals?
I don't think it's a
No.
hammer,
No, but in terms of what are you trying to do? Or is that just a general
It was just a
question?
general question.
Okay, stoichiometry, you may see also use they use it in labs, obviously, to create different medications, different pills, but then also like in airbags. Airbags.
For
cars. In
Okay,
cars
for
and
cars. So engineers, if you're going into engineering, this is going to become like your best friend. Because you have to keep in mind that when you're dealing with creating like airbags, you have to make sure that you have the proper amount of air inside the bag, so that the proper amount of air actually kind of like
I'm not going to mechanical engineering.
is dispersed as like a collision occurs. Because if you have too much air, okay,
Suffocate them.
you can, yeah.
Can't you break their nose
You
and stuff like
can
that too? When you put too much
easily break your neck
Yeah.
or whatever, okay? And then if you have too little, then of course because of the metals in there as well, you can really damage yourself. And then along with the airbags, once they go through, the nitrogen gas, there's a nitrogen gas that also kind of explodes if it's in contact with water. So in order to produce that, they use like the sodium iodide, and that's kind of used to kind of that's pretty